Hello guys, a very good morning to my beloved lecturer, Madam Yoga Devi and my fellow friends. Today I gonna present about topic 3 hydronomics, which is the fluid flow of laminar flow, transition flow and turbulent flow. Before I go into the presentation, I would like to introduce myself. My name is Vishnu Aniki Gopal Krishnan with metric number of 15DK823F1013. So let's go into the presentation. So let's start with the introduction. What is hydronomics? Hydronomics is the study of the economic aspects of water resources and their management. It encompasses the analysis of water as an economic good, including its allocation, pricing, and impact of water policies on various sectors such as agriculture, industry, and domestic use. The discipline examines the interplay between water availability, demand, and environmental sustainability, seeking to optimize water while addressing issues like scarcity, pollution, and equitable distribution. Hydronomics often incorporates tools from economics, hydrology, and environmental science to inform decision making and develop strategies for efficient water resources management. So, there are three types of fluid flow. First one is laminar flow, second is transition flow, and third is turbulent flow. So, we'll get more detail in the next slide. Before that, I would like to introduce the formula of Reynolds number. What is Reynolds number? The Reynolds number equals to rho times V times D over dynamic viscosity, or rho or Reynolds equals to V over V times D over V. So what is rho? Rho is density of fluid, which is kilogram per meter cube. V equals to velocity of flow, meter per second. D equals to diameter of pipe, meter. U equals to dynamic of viscosity, Newton second, millimeter meter per second over meter per second. So V equals to kinematic viscosity, meter cube over second. So we'll get into the laminar flow first. In laminar flow through a pipe, fluid flows in smooth parallel layers with no distribution between them. The velocity of the fluid is highest at the center of the pipe and gradually decreases towards the wall, where it becomes zero due to no slip conditions. The velocity profile forms a parabolic shape with the maximum velocity at the center and gradual reduction towards the edges. The flow occurs low velocities and typically seen when the Reynolds number is below 2000. The movement is orderly with no turbulence or mixing between the layers of fluid. So the examples of Reynolds number calculation is Re equals before that density equals to 1000 kilogram per meter cube. U equals to the dynamic viscosity equals to 0.01 Pascal, following at the V equals to 0.5 meter per second in a pipe of distance of 0.05 meter. So Reynolds, after inserting the numbers in Reynolds number formula, Reynolds equals to 1000 times 0.5 times 0.05 over 0.001 equals to 25,000. Since Reynolds more than 2000, this would indicate turbulent flow in this case. To get laminar flow, the velocity of pipe must be reduced. So the example diagram of laminar flow is this. So next, what is transition flow? In transition flow through a pipe, the fluid behavior is mixed between the laminar and turbulent flow. This occurs when the Reynolds number is between approximately 2000 and 4000. The flow starts as laminar near the entrance of the pipe but becomes unstable, with the fluxion developing as the velocity increases. The disturbance grew into irregularities or swirls, signaling the onset of turbulence. The velocity profile starts smooth like laminar flow, but inconsistencies begin to appear, especially near the pipe walls, leading chaotic motion in some regions while other areas remains orderly. So the example of Reynolds calculation is consider water with a density of 1000 kg per meter cube and dynamic viscosity equals to 0.01 Pascal through flowing through a pipe with a diameter of 0.05 meter and the velocity of 2 meter per second. The Reynolds number is calculated as 1000 times 2 times 0.05 over 0.001 equals to 100,000. Since Reynolds is large, the flow is turbulent. Lastly, what is turbulent flow? In turbulent flow through a pipe, the fluid moves a chaotic, irregular manner with rapid fluctuations in both velocity and pressure. Unlike turbulent flow, is characterized by the formation of swirling eddies and vortices throughout the pipe. The velocity profile flattens out as mixing occurs across the entire cross section, and the fluid particles move in various directions, not just along the pipe axis. Turbulent flow typically occurs when the Reynolds number exceeds 4000, leading to higher energy loss and greater friction along the pipe walls. So the examples of Reynolds calculation consider air with the density equals to 1.225 kg per meter cube and dynamic viscosity equals to 0.000181 Pascal, following it over a flat plane with the characteristic length of 0.1 meter at the velocity of 15 meter per second. The Reynolds number is calculated as 1.225 times 15 times 0.1 over 0.000181 equals to 101,384. Since Reynolds is significantly above 4000, the flow is turbulent. So the examples of diagram of turbulent flow is this. So we have came to the conclusion. The conclusion is the study of hydronomics encompassing laminar flow, transition flow and turbulent flow in crucial optimizing fluid system across various industries. Laminar flow characterized by smooth, orderly movement in vital application requiring minimal friction and energy loss such as microfluids and lubricant. Transition flow represents the critical point where flow behavior shifts, and understanding it helps in predicting and managing changes in flow efficiency and stability, while turbulent flow with its chaotic mixing plays an essential role in enhancing heat transfer and mixing in system pipelines, combustion engines, though it also increases drag and loss energy. Mastery of this flow requirements allows for the design of more efficient and effective system in engineering, environmental management and industrial application. That's all from me. If you got any question to be asked, you can comment in the below or in the comment box. That's all. Thank you so much.